welcome to my talk, Simple Gestures Can Go a Long Way. Before I dive into it, here's a little bit about myself. My name is Gerard. I'm currently a developer advocate at Stripe. If you don't know what Stripe is, we're a fintech company, so we handle payments for different clients. So if ever you need to have payments handled on your website, then we do that pretty well. So feel free to check us out. But what I do there is, as a developer advocate, I work in the engineering team, and I collaborate with our product team to test out the feature that we're about to release to people, so I can give feedback and make sure that we provide the best experience possible. And also, after we release products, I'm in charge of finding different ways to help developers use our products through educational materials like videos or blog posts. I also help maintain our open source SDKs and anything that's related to that. Apart from that, I'm also the author of a book about machine learning in JavaScript, and I'm part of the Google Developer Experts group, and my specialty is in web technology. So if you've never heard of this group, it's a community group sponsored by Google for people who are quite active in the developer community. As a front-end dev, my specialty is web technologies, but if you're interested, you can find some information online if you're into Android or machine learning or a lot of different tech stuff. And, I'm also a self-proclaimed creative technologist. I absolutely love exploring how far I can push the boundaries of what can be done on the web. And hopefully I'll show you a little bit of that in this talk. All right, so let's get to it. I want to start at the very beginning with talking about human-computer interaction. In a very broad definition, HCI is a subfield of technology that is focused on the interaction between humans and computers in terms of inputs and outputs. So in your day-to-day, it includes using a mouse, for example. So when you use a mouse, a cursor moves on the screen. So the input is you moving the mouse, and the output will be the cursor moving on the screen. It also involves a keyboard. So when you press keys, that would be the inputs, and you have letters displayed on the screen, that would be the outputs. But it also includes touchscreens and voice assistants, any way really that you interact with technologies. It's something that as developers, and especially me as a front-end developer, we might not hack on very often. Most of the time, we rely on standards that are already available, and we just use them through web APIs. So we didn't define that a mouse can or should be clicked, but we use these interactions through on-click events or on mouse down, etc. But it's not because most of us don't define these standards that we can't explore that space and experiment with other ways to interact with interfaces. You could ask yourself the question, if there wasn't a mouse or a keyboard, how would I love to actually interact with a screen, or even maybe not a screen? And an example of that is with motion detection. So if I ask you to think right now about motion detection in your day-to-day life, you might think of something like this. So it's a standard motion detector that is used to turn lights on or off in your office or outside your house. It could even be a security alarm system, but that's pretty much it. What it detects is basically, is there movement or not? It doesn't particularly detect specific movements. For example, it doesn't know if you're walking or running or jumping. It doesn't even know if the movement is from a person, an object, or an animal. But the thing to know, though, if you're interested in this, is that if you ever want to build your own standard motion detection IoT device as a developer, you can. You can use an Arduino, for example, or a Raspberry Pi, depending on if you already have one around. And with a motion sensor, like either a small radar or a PIR sensor, you can get data and customize an application all using JavaScript. But these two sensors that I mentioned, so the small radar and the PIR sensor, they're just as standard as the one that you can buy in store, meaning that they can detect that there's some kind of motion, but that's it. However, movement is much more complex and interesting than is it just happening or not. You can have contextual information associated with a movement. For example, even just the time of day or the location. For example, if you're tracking the movement of your legs while you're running, and you happen to be at the gym in the evening, it is different than if you're running outside in the morning. In one instance, you're exercising, and in the other, you might be trying to catch a bus. So even though the movement itself might be the same, there is extra information necessary to understand what's going on. But also in the movement itself, it is more complex than just an on or off state. So is it happening or not? For example, if I do a thumbs up, it means something else than if I'm waving my hand. And if I'm raising my hand to speak in a meeting, it means something different than if I'm raising my hand or the way that I raise my hand for a taxi to stop, for example. So can we take advantage of the complexity and all the data around movements to build smarter, more customizable interactions as front-end developers? Well, the answer is yes, and this is why I'm giving this talk today. So it's definitely possible, and even better, it's possible in less than 50 lines of code. The first step is to use a microcontroller with a built-in accelerometer and gyroscope sensor that is called the Arduino Nano 33 BLE board. So it's a long name, but as there's a lot of different types of Arduinos, if you are interested in recreating a similar project than the one that I'm going to show you a bit later, it's going to be easier if you use that board. It is super small. I have it here. It's like the size of my thumb, and it costs a bit less than $40 at the moment in USD. And the reason why you would need a board with an accelerometer and a gyroscope is because you get 3 points of data for how your body rotates with the gyroscope and 3 points of data for how fast your body moves with the accelerometer. So these 3 points of data are the X, Y, and Z coordinates of your movements. So when you rotate, you can rotate like this, and you can rotate like this, and you can rotate like this. So you get these coordinates for both attributes, so rotation and acceleration, multiple times per second. And it gives you quite a lot of data to be able to differentiate multiple movements. Okay, so that's for the hardware part. But how do you actually get this data and do something with it? So for the software part, we're gonna do some machine learning using TensorFlow.js and Arduino. If you've never tinkered with Arduino, don't worry, you mostly need to upload a pre-written sketch to the board, and you don't have to write any C code if you don't want to. By default, when you plug the Arduino into your computer, it's not ready to handle any machine learning functionality. It doesn't have that built-in logic. So the sketch that you upload onto the board adds the logic to communicate with the browser via Bluetooth and receive a machine learning model from the browser and run it live with motion data. So that part of the code is in C. But with JavaScript, you can do everything else. What I mean by that is you can use the Web Bluetooth API to connect the Arduino to the browser and receive data. You can process that data using standard JavaScript. And by processing, I mean that when you receive data or from the Arduino, it's an array of a lot of integers. And you need to do some transformation on that data because TensorFlow.js needs to work with a different format of data. And then with TensorFlow.js, you can create a machine learning model, train it, and export it, and all the things. So you can do everything on your own from scratch if you want to, or you can also use a project built by Google Creative Labs called Tiny Motion Trainer. It allows you to do all of the steps that I just mentioned. So connecting to the board, getting data, transforming it, building the model, training it, all of the things, but in just a few minutes via UI. So I'm going to show you quickly how this works. All right, so when you get onto the platform, I'm going to start a new project. And the first step is to connect the Arduino to the computer. So I'm going to connect it here. And I have my little Arduino that is ready to be connected. And when it's paired, you can see on the first setting here that it's moving. So if I don't move the Arduino that much, the graphs don't move. And if I move it a lot, it moves a lot. So I will talk about these settings a bit later, but for the purpose of this demo, I'm just going to go straight away to capturing the data. So when you capture the data, we're going to pick two different gestures. So I'm going to start with wave. So I'm writing wave, and I'm creating the new gesture, and I'm going to hold the Arduino in my hand. I'm going to start, and I'm going to wave. I'm waving, hello, waving. And I'm going to start at 10. Okay. And here you have the visual representation of the gesture waving. And I'm going to pick another one. So swipe, and I'm going to create, and I move to swipe. And again, I'm holding it in my hand, start recording, I'm swipe. Yeah, of dollar bills. And yeah, okay. Ooh, I recorded 11, but that's all right. So you can see here that the representation of the gesture wave is visually different from what a swipe is. And you can be pretty confident when you can see, the difference with your eyes, that a machine learning model is also going to be able to see this difference. So the next step is to train your model. And this is going to train a machine learning model live in the browser, which is really cool what you can do now with JavaScript, and should take just a few seconds because I only trained 10 samples for 2 different gestures. Okay, and now we can move on to testing your model. So I have my 2 gestures on the screen here, and if I wave, it should be a wave, and if I swipe, swipe, so wave, swipe, wave, swipe, and we can be pretty confident that it's working. The next step that you would do usually is to download your model, but I don't need to do this right now because in the demos that I'll show you later, I already have a model in my files. All right, so if I go back to my slides, I'm going to need to... So if you want to dive deeper into this project, it is open source, which is awesome. So you can check it out if you want to learn more about how it works in the background. But now that we've trained a machine learning model with 2 different gestures, how do we actually use it to add gesture control to a web app? So the team at Google Creative Labs that created Tiny Motion Trainer also provided a JavaScript library that you can use to quickly and easily load and transfer the model, so from your project to the Arduino, and then get predicted gestures back to the UI. So you might be wondering what's in this mysterious script. Unfortunately, I don't have the time in this talk to dive deep into it. The script is about 1,000 lines of code. But to understand it better, I did spend time reverse engineering it, and you can get the basic functionality in about 350 lines of code. So if you really wanted to dive deeper into it, you could even try to recreate it yourself if you want. But at its core, what it does is it handles the communication between the Arduino and the browser via Bluetooth. So at the beginning, I told you that you upload a sketch to the Arduino that is going to create what is called services and characteristics that kind of represents variable that will hold different values on the Arduino. It's part of the way that Bluetooth works. And the script in the browser is going to look at the name of these variables, so that use different unique IDs. And it's going to set up the communication between these 2 so that we can get data from the browser and write it to these characteristics on the Arduino. And then the second part of the script is to split the machine learning model in our app into chunks and then send that to the Arduino, to the characteristics on the Arduino, so that it can handle the whole functionality of predicting new gestures. So but at your level, if you just want to do what I'm showing in this talk, you only need to add a script tag. You actually don't need to dive into it if you don't want to. So once you add the script into your app, the code that you have to write, though, is actually very small. So adding this script to the app will make available a method on the window object that is called Tiny ML Experiment BLE interface. So it is a very specific name, but at least you can be sure that it won't conflict with anything else that is available on the window object. And in that method, you can call a create connect button, and you're going to pass different parameters to your model and get gestures detected. So first, it creates a button on the page to connect to the Arduino device. And the reason why it does that is because with the Web Bluetooth API, to start a connection to a device, you need a user action. And usually it's a click on a button. For security reasons, you don't want your browser to connect automatically to whatever Bluetooth device is available around. So at first, it creates a button on the page. And then you're going to pass your model's parameters. And the first one is the path to the file. So if you remember Tiny Motion Trainer, you download the file at the end, you add it in your folder. And an awesome thing about TensorFlow Lite, so TensorFlow Lite is like the type of files that you export. They're pretty light. So I guess it's like, TensorFlow Lite. But my custom model with 2 different gestures is only about 16 kilobytes of data. And it's actually pretty amazing for machine learning because when I've done other experiments with machine learning before, especially around object detection, for example, the models that I have to use are usually multiple megabytes. So when you have to fetch that kind of resource, you can imagine the impact that it has on performance. But with a 16 kilobytes file, that's okay. I mean, at least especially for machine learning, I'm pretty impressed. Then we have to indicate the number of classes or the gestures that we trained. In this case, I trained 2 gestures, so I have the number 2. You can train a lot more gestures. I haven't tried it with that many, but I welcome you to try. And then we have the threshold, which is a value between 0 and 1. And it represents the threshold at which the model will start to classify a certain gesture. So it doesn't try to classify very slight gestures like my arm moving super slightly, for example. So the closer to 0, the more sensitive it's going to be. And the closer to 1, you'll have to execute a pretty intense gesture for it to start trying to predict it. Then the number of samples is the number of samples. So here, I wrote 10 because I wanted to record only 10 in the interface. I wrote like one of them was 11. So if I was updating that code with the model that I was training live, I would probably write 11. And then the capture delay is the delay between samples of data used to recognize gestures. So the closer to 0, the faster it's going to look at new live data to predict a gesture, and the closer to 1, the slower. These things are a bit, it's not set in stone. So you can pick your own values. It depends on what you want to create and how sensitive you want the prediction to be. And then you have a few different events available, such as on connect, if you want to display something in the UI when the board is connected to the browser. You have on transfer progress, if you want a loading bar, so that when the model is uploaded to the board, you can have access to the transfer progress. You can have on disconnect if you want to tell your users that the board is disconnected. But more importantly, you have on inference. And this function executes when the code on the device has predicted a new gesture in new live data, and it notifies the front end. So we can then access the index in the data object, and this index represents the index of the gesture trained. So 0, 1, 2. So my first gesture could be 0, my second gesture would be 1, etc. And finally, based on this index, you can trigger any kind of front-end code you want. It could be visual animations, it could be sounds, it could be a checkout process, like you can pay by doing a swipe. Like at this point, it really is whatever you want. And that's pretty much it. The code that I showed you in these past few slides, that's all you need. It's 50 lines of code plus a script that is pre-written for you to add new interactions to the browser. So it's really focusing on letting you create and invent new ways of interacting. And then if you want, the code is open source if you want to dive a little bit deeper. So to recap, you have to start by uploading an open source sketch to the Arduino. Then you train your model in Tiny Motion Trainer in a few minutes or less, and you export it into your app folder. And finally, you can add the TF4 Motion Kit script to your app and write some JavaScript and create your own interactions. So to show you an example of what you could build with it, I have a few different demos to show you. So the first one is something that I called Air Street Fighter. So the first version of this project, I created it in 2019. It uses 3 different gestures to animate a character on the screen. And the first version of this project didn't use Tiny Motion Trainer because it didn't exist at the time. That project wasn't there. So all the steps that I told you at the beginning of this talk, so connecting to the board, collecting data, creating the model, training it, testing it, all of it. So I did it by myself, so from scratch. So this is why I'm telling you it's possible. It was really fun. But then when Tiny Motion Trainer was released, I actually wrote a second version of that to replace it, and it was a lot faster. So I'm going to show you quickly a little demo. Hopefully it's going to work, but that should be fun. All right, so the first step here is to connect to the board. It should display, yes, okay. It displayed the board here. I got scared for a second. And it's going to start. So what it does now is transferring via Bluetooth a machine learning model to an Arduino. This is super cool. I want to write a blog post to go a bit deeper into how transfer actually works, but I didn't have the time yet. But anyway, then I can start, and I should have my 3 different gestures. So if I do, well, that's not the one I wanted, but it works, it does something. So if I do, yay, and that's also not the one I wanted. Well, yeah, it does things. So I do movements. Maybe I'm a little bit more restricted in my space right now giving this talk. But yeah, basically that's what it does. I have like a punch and a thing and another thingy, and it does something on the screen. Yes, okay. So I need to go back to my talk, but okay, so that was for the first demo. But then if maybe you're not interested in games, maybe you're interested into music. And what you can also do with that type of technology is to do some kind of air drums. So a few years ago, I built my own kind of air drums experiment. It wasn't using this board and Tiny Motion Trainer. It was using devices called free drums, but the concept is the same. You train certain movements in space, and then you can trigger whatever animation and sound. So if you're into, I don't know, if you're playing music at concerts or whatever, then you could use that to make your experience a little bit more interesting. And actually, so I built that with that Tiny Motion Trainer, but there's another project available called Air Snare that is very similar, but using Tiny Motion Trainer and the Arduino. So I welcome you to try if you end up getting an Arduino and want to try that experiment, but it's the same thing. And an interesting thing about this project is that you don't actually have to always retrain the model with your own gestures. So if you pretend that there's a drum in front of me, it doesn't matter if it's me or somebody else doing the gesture to reach different parts. So with this project, you can connect to the board. You don't have to go through the training process, and you just do some kind of air drums and it makes sounds. But maybe you're not into games or music, and maybe you're into fitness. So I'm not going to demo this one, but in this example, the Arduino is attached to the leg and not the hand. So you don't have to always hold the Arduino. Anything that creates movement can actually be attached to the Arduino. And you can train Tiny Motion Trainer to understand what a squat is and make your own fitness app. Or, you could say that you're not allowed to touch your phone until you've done 50 squats, or, it's really then up to you, which I really like. That the interaction is then up to you. And there's a lot more that can be done with Arduino and machine learning in JavaScript. I don't have the time to get into it today. So on this, thank you so much for listening. Hopefully you learned something in this talk, and maybe it gives you some ideas of projects that you want to build or technologies that you want to try. If you have any question, I'll be, feel free to ask in the Q&A. You can let me know. But if nothing comes to mind right now, no problem. You can reach me later. I'm DevDevCharlie on Twitter, or otherwise I'm Charlie Gerard in real life and around the internet. But thank you again, and I hope that you enjoy the rest of the conference.